Hello everyone, welcome to my YouTube channel Spot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about the working and functionality of 3:8 decoder and 4:16 decoder. Also, we are going to discuss about RTL design implementation of 3:8 decoder and 4:16 decoder by using System Verilog. Okay, before watching this video, I request you please go and watch my one of the previous video of RTL design implementation of 1:2 decoder and 2:4 decoder, where you will get to know about working and functionality of 1:2 decoder and 2:4 decoder. Now let's get start with the basic understanding of decoder. We know that it's a combination circuit which converts binary input into the particular distinct output signals, and it activates one of the input line at a time based on the input binary values. Okay, and basically it has n inputs line and 2 to the power n output lines. Means if the select line are 2, then output will be 4, so that will be 2:4 decoder. If the select lines are 3, then 2 to the power 3 means 8 outputs, so that will be 3:8 decoder. Okay, and it is used to generate either active high or active low output. And in practical applications, decoder are used to select one of the memory or input output device at a time. Now if I talk about working and functionality of 3:8 decoder, so if you see, it has one enable line and 3 select line, that is S0, S1 and S2. Based on the select line, particular output will be generated. So as we are having 3 select lines, so 2 to the power 3, that means 8 output lines. Based on select line, at a time any one output will be activate. Okay, now if I talk about truth table of 3:8 decoder, so here you can see that the output Y0 will be activate when and only all select line S0, S1 and S2 are low with enable bit high. Then only Y0 output Y0 will be activated. At that time other outputs will be low. Similarly, when select line S0 is high and S1 and S2 are low, then output Y1 will be active. Okay, so similarly with all the outputs Y2, Y3, Y4, Y5, Y6 and Y7. When Y7 will be activate, when all the select line S0, S1 and S2 are all are high, then only Y1 will be activate, and at that time other outputs will be low. Okay, now if I talk about block diagram of 4:16 decoder, so it has one enable line and 4 select line. So based on 4 select lines, we are having 16 outputs. Okay, if S0, S1, S2 and S3 all select lines are 0, then output Y0 will be active that time. If all select line S0, S1, S2 and S3 are high, then output Y15 will be high. If I talk about truth table of 4:16 decoder, so here you can see that if my S0, S1, S2 and S3 all select lines are low with enable bit high, then output Y0 will be active. Other outputs will be inactive that time, means other outputs will be low, only Y0 will be high. Okay, similarly for all the outputs, that is Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, Y9, Y10 up to Y15. When Y15 will be activated, when all the select line, that is S0, S1, S2 and S3 are high, then only output Y1 will be activated. At that time all the remaining outputs will be low. Now let's jump to the RTL design implementation of 3:8 decoder by using System Verilog on a Vivaldi. So you can see my screen. I have already written and System Verilog code for the RTL design implementation of decoder 3:8 decoder. So let's go through the code. My module name is decoder 3:8. One of the input is enable and 3 select line, input select line, that is S0, S1 and S2, and 8 outputs from Y0 to Y7. Okay, and here my tick time scale is 1 nanosecond divided by 1 PS. Now there are two ways through which we can implement the 3:8 decoder. One is by using combinational procedural block and another is by using assigned constructs. Both ways are good, only we can use one of the ways. Now if I try to implement the 3:8 decoder by using assigned constructs, then we have to follow the boolean expressions for each output. you can see the boolean expressions for each output, that is for y0, y1, y2, y3, y4, y5, y6 and y7. I have taken this boolean expression from truth table. Okay, let's see the boolean expression for y0. The boolean expression is enable and not of s2 and not of s1 and not of s0, means if all select line are 0, then y0 will be activated. Okay, if my select line s0 is high, s1 and s2 are low, and with enable is high, then y1 will be activated. Okay, similarly for all the outputs, so from y0 to y7. Okay, now if I execute this code, then I'll get this kind of schematic. Here you can see output y0, y1, y2, y3, y4, y5, y6, y7, and with within the gates. Okay, now the another way is by using combinational procedural block. So what I will do, I'll comment this logic of assign construct, and I'll uncomment this logic of combinational procedure block. So if you are trying to implement 3:8 decoder by using combinational procedural block, then we can use a case statement, and we know that case statement says that for every possible output we should have assigned every possible inputs. Okay, so based on select line output input will be assigned to the outputs. Okay, so here you can see if my select line is 0, then I have assigned 1 to the output y0. At that time, at this time only my y0 will be activated, but remaining outputs, that is from y1 to y7, will be inactivated. So I have assigned 0 to all the output, that is from y1 to the y7. Similarly, for if my select lines are 1, that is s0 is 1, s1 is 0 and s2 are 0, indirectly select line is 1, then that time my output y1 will be activated. So I have assigned 1 to the output y1 and 0 to the others output. Similarly for all the select line, for select line 2, 3, 4, 5, 6 and 7. Okay, now I'll save this, and if I click on even if I click on this reload, then it will generate the schematic for this combinational procedure block. Schematic. Okay, one of my enable line input s0, s1 and s2 are the select lines. Okay, these are the RAM, these are the muxes, and these are the output from y0, y1, y2, y3, y4, y5, y6 and y7. Okay, based on select lines input are assigned to the outputs y0. Okay, now to verify this 3:8 decoder, I have written a simple verification TB code, where you can see enable and select line s0, s1, s2 and outputs y0, y1, y2, y3, y4, y6, y7, and this is the instantiation where I have used dot star, that is it will automatically added all the instance, because our inputs and output of the design code as well as the TB code are same, so that is the reason we can add this operator. Okay, and inside the initial begin I have assigned some values for the enable for input enable and input select lines. Okay, now if I click on this run simulation, then it will give me the waveform. Okay, so basically so here you can see that I'll zoom it. Okay, now here you can see that my enable is high. Okay, and when s0, s1 and s2 all are low, then my y0 is high. When s0 is high and s1 and s2 are low, then y1 is high. Okay, for next cycle you can see my s0 is low, s1 is high and s2 is low, then my y2 is activated. That time my all other outputs, that is y0, y1, y3, y5, y6, y7 are inactivate. Okay, similarly where you can see in the next cycle when s0 is high, okay, s1 is high and s2 is low, that means s0 and s1 are high, means it is value 3. My select line is 3, then you can see my output y3 is high and remaining output that is y0, y1, y2 and other are low. Okay, for the RTL design implementation of 4:16 decoder by using System Verilog. So here you can see that I have already written and System Verilog code for the design implementation of 4:16 decoder. Okay, let's go through the code. Static time scale is 1s divided by 1ps. Module name is decoder 4 to 16. I am having two inputs, that is input enable and 4 bit of select line and 16 bit of output y out. Okay, here also I have implemented 4:16 decoder by using two ways. One is by using combinational procedural block and another way is by using assigned constructs. To implement this decoder 4:16 decoder by using assigned constructs, we have to follow the Boolean expressions. I have taken these Boolean expressions from the truth table of 4:16 decoder. Here you can see the output assign statement for output 0 for output y out of 0, where my select line is 0. That means select bit of 0, select bit of 1, select bit of 2 and select bit of 3. All bits are 0 and with enable that is assigned to the output y, output y out of 0 bit. That means for select line 0, my output 0 will be active and remaining outputs will be inactive. Okay, remaining outputs will be inactive that time. For when my select line is 1, then output y out of 1 will be high. When select line is 2, then output y out of 2 will be high, other outputs will be low. Okay, similarly for all the output from 0 to 15. Okay, when my select line is 15 means select 0 of select 1 and select 2 bits, select third bit, all bits are high with enable bit, then output y out of 15 with 15 bit will be high. Okay, now if I execute this code, then it will give me this kind of schematic. So here you can see that I input enable and select for 4 bit of select line, and with all here and operations are performing because I have used that get, and the output y output, that is common. Okay, now now let's check with another way. Now I'll comment this code. Okay, slash r. I'll uncomment this combinational procedural block. So now one thing is, to implement the design code of 4:16 decoder, you can use both the ways. Both ways are good at their own position. Here you can see that in combinational procedure, as I am using case statement for the select. So based on select line, my output will be high, and we know that case statement says that for every possible output, we should have assigned input value. Okay, so you can see that when select line is 0, then in my output only 0 bit is high. That means y out of 0 is will be high and remaining bits are 0. When select line is 1, then output first bit of output will be high and remaining bits are 0. I have assigned remaining bits to the 0, so that in unintentional latches do not should not be occurred. Okay, with this code unintentional latches will not occur. And if we now, I'll save this code and I'll click on this reload, then it will give me the schematic of this combinational procedural block, where it will include some kind of RAM and muxes. Okay, I can see the schematic, my select line. Okay, I'll keep it. Here you can see the schematic, my 4 down to 0 select line, this ROM, and this is the one mux and enable. So based on the select line, particular output will be high. Okay, if select line is 0, output y out of 0 will be high. Okay, now to verify this 4:16 decoder, I have written a simple test bench code. So here you can see module TB for decoder 4:16 bit enable, then 4 down to 0, 3 down to 0 means 4 bit of select line and 16 bit of y output. As my inputs and output of TB as well as design are same, so I have instantiated like this. Okay, and inside the initial begin, I have given the select line and the enable bit. Now if I click on this run simulation, then it will give me the waveform. So here you can see when my select line is 0, when my select line is 0, my 0th bit of output is high. Okay, that time you can see all other bits are low. When my select line is 1, then output of first bit is high, other bits are 0. When my select line is 2, output of other bits are output of other bits are low, only second bit are high. For 3, third bit is high. For 4, for select line 4, fourth bit high. For select line 5, my fifth bit is high. For select line 6, my sixth bit is high. As we have already seen this on the truth table of for here you can see that if my S0, S1, S2 and S0 all are 0, that time only Y0 is high, remaining Y1, Y2, Y3 are 0. Similarly for means select line is 0, if select line is 1 then output Y1 is high, if select line is 2 then output Y2 is high. Similarly behavior we can see here in the waveform. Okay, so basically in this video we have discussed the working and functionality of 3:8 decoder and 4:16 decoder. Also we have implemented RTL design implementation of 3:8 decoder and 4:16 decoder by using System Verilog. There also we have seen two ways. One way is by using assign construct and another way is by using combinational procedure block in both implementation. So here I will stop the video. Hope you understand this video. If you didn't understand, then please watch again. If you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.